Hey Dr. Sawyer, skill number 3, and basically it asked me to choose 3 angles that had reference angles of pi over 6, pi over 3, pi over 4, and a quadrantal angle, and I chose 2 pi. And here's my pi over 6 reference angle, which is regular pi over 6. My pi over 3 reference angle is 2, so if this is pi over 3, this must be 2 pi over 3, so then that's my angle that I chose for that reference angle. For the pi over 4 reference angle, I chose this one, and that's 5 pi over 4. Once again, quadrantal angle, 2 pi, which is going to be right here. So then first I just set this up by demonstrating the common triangles that are going to show up in the unit circle. So this is basically the 30, 60, 90, 45, 45, 90, and I labeled each side corresponding. Across from the 60 is root 3 over 2, across from the 30 is pi over, or just 1 over 2. Across from both of the pi over 4s, you have root 2 over 2, and you have 1 as both of the hypotenuses. Hypotenusae, I guess. And so basically what I did, it asked you to find sine and cosine of just choosing one of the angles, so then I just chose pi over 6 because that was the first one. So then I just redrew the scenario basically according to where it was on the unit circle. So both this is positive and that's also positive. So sine is asking me for sine, so that's opposite over hypotenuse. So I took 1/2 over 1, and that's obviously 1/2. So sine pi over 6 is equal to 1/2. It asked me for cosine. Cosine is adjacent over hypotenuse, so I took root 3 over 2 and I put it over 1. You get root 3 over 2, so that's that. For B, it asked for the same thing, but it was sine and tangent, and it was just a different angle other than the one you chose in A. So then I chose the reference angle of pi over 3, and that actual angle is 2 pi over 3. And so I redrew the angle in the correct scenario. So since it's behind the y-axis, it's negative 1/2. It's still above the x-axis, so it's root 3 over 2. So then it was asking for sine. So then I took the opposite side length and put it over the hypotenuse, and that's 1. So anything over 1 is going to be itself, so you still have root 3 over 2 as your sine for 2 pi over 3, and tangent is going to be opposite over adjacent. So then here's the opposite side length, here's adjacent side length. So then when that all cancels, so when you simplify this math, you flip this, because when you divide by a fraction, you're multiplying that by the reciprocal. So then you multiply that over, the 2's cancel out, you're just left with negative root 3 over 1. Anything over 1 is itself. So then tangent 2 pi over 3 is equal to negative root 3 right here. And then going on to the back. C asked for the same thing, but not just use a different angle. Still sine and cosine though. So this time I didn't really want to do the quadrantal angle until last. So I chose the last one with a reference angle of pi over 4, and the actual angle was 5 pi over 4. And so in this scenario, since it's behind the y-axis and below the x-axis, both of these values are negative. So I was asking for sine and tangent. So sine, this is a reference angle right here, so you're doing sine, which is opposite over hypotenuse, comes out to be the same thing because it's over 1. So negative root 2 over 2. For tangent, it's opposite over adjacent, so then it's the same thing. So same thing over itself is going to equal 1. So tangent 5 pi over 4 is equal to 1. And then for D, it was the very last one, and I saved the quadrantal angle for last, and it asked for sine and tangent as well. So basically what I did was it asked for sine, so that's opposite over hypotenuse, and there's no what's it called? There's no opposite side length. The opposite side length is 0. So then 0 over the hypotenuse is going to be 0. So sine 2 pi is also 0. Tangent, same thing, opposite, but adjacent now. So now it's 0 over adjacent, and that's 0 divided by adjacent is going to be 0. So tangent 2 pi equals 0. And yep.